Hello. I see the folks that got A through F done. I think only one person got one wrong. So that's good news. So we have all those taken care of. And we're on to 9. And so let's see. We've got 9, 10, and 11. So that will be your homework, is to do 9 through 11 for homework tonight if you can. Let me zoom that in a bit and straighten it out. There we go. So that's not so bad considering we're going to do 9 right now together. So yeah. Okay, so let's look at 9. We know that this is a Gay-Lussac's law problems, which is dealing with pressure and temperature. So we'll start by writing down the base equation. P1 over T1 equals P2 over T2. That will help us gather our thoughts. And if we want to create a data table, we could do that, or we could just plug stuff in. One of the things that you can do as you're reading the problem maybe is just attach things together. And I know that there's certain folks that like to do stuff quick. So if you want to take a shortcut, this might be something you'll pay attention to and want to try. So if I read here, I see that I have a 2-liter bottle that's containing only air and it's sealed at this temperature. That connects these two things together. Oh, and a pressure here. So those 3 things are actually linked together. It's interesting that they gave us a volume. The bottle is placed in a freezer and allowed to cool to 3 degrees Celsius. What is the pressure in the bottle? So it looks like the 2-liter bottle doesn't change. And, you know, the same 2-liter bottle is being used in both things. So volume isn't changing. If it doesn't change, we don't need to include it in the calculation. So that could throw you off. You might be thinking, oh boy, why did they give us that number when we're not going to use it? Good question. Maybe it's to prep you for the next gas law that we're going to discuss tomorrow, to get you used to the idea that you may or may not be needing something. But remember, if the volume, that's not a V. Let's make a V out of that. Oh my gosh, let me start over. Goofball. If the volume, temperature, or pressure is unchanged, you do not need to include it. And we'll touch on that more as we move along to the next gas law, which will be tomorrow. So, but for today, we are looking at the problem. We see that we've got this bottle. It's got air at 22 degrees Celsius and a pressure of 0.982 atmospheres. And it's placed in the freezer. It's allowed to cool to 3 degrees Celsius. And what is the pressure? So see how I saved myself having to write out an extra data table by me doing that? But I know a lot of you don't like messy, and this is a little messier. So you might want to just decide on your own. We're solving for P2. So in order to rearrange this equation, I'll leave P2 alone on that side of the equation, and I'll move the T2 over, and the T1 stays right where it's at, and the P1 stays right where it's at. So with those things in mind, we can plug in our numbers and solve. So in order to do that, I wonder if I can fit it into the space. If I write small, maybe I can. So I've got P1 is 0.982 ATM. I've got T2 is 3 degrees Celsius plus 273 because we need to get it into Kelvin. And T1 is 22 degrees Celsius plus 273. So that's going to give us P2. Oops, where's my calculator? La la, buried. There it is. Okay, so let's give it a shot. We're going to take the 0.982 and 273 plus the 3, multiply those together, and then and we'll divide the bottom and the top, or the top from the bottom, and we end up with 0.091. I think I only have 2 significant digits. Yes. So that means I'm going to leave it there at 0.09, and that is atmospheres. Okay, so that's how you do those. And you only have 2 problems to do tonight, and tomorrow in fact, why don't we not even fill out a Google form? I'll have just keep your answers on the paper, and then tomorrow I will add 9, 10, and 11 to tomorrow's Google form, which is going to be covering the combined gas law, which is our next step. And so tomorrow we'll have a little bit more homework than today. So either way, get it done. Enjoy.